Okay, this is part 3 of static electricity. In this section, we will be focusing on some of the applications of electrostatic charging. How is it useful and how is it dangerous? Okay, so these are the learning outcomes. Okay, you can take a look at these comic strips. Okay, there is a lightning striking a tree, and then the girl was saying, "Phew, we would have been seriously injured or killed if the lightning struck us." And then the other guy was starting to think, huh? Is lightning always harmful? Could it be useful as well? So it's important to note that we are trying to harness the electricity from lightning because lightning gives a lot of electricity. So there are some advancements such as the use of laser to create a path of ionized gas to direct the current towards specific harvesting stations. But as of now, we are still unable to harness electricity from lightning because we are still unable to find things that can cope with the very large and fluctuating current caused by lightning. Okay, so one of the most dangerous parts of electrostatic is charging by friction. So whenever you have a fluid flowing through a hose or a pipe, it actually results in charging by friction. It results in the build-up of electrostatic charges. So in this case, you can see the diagram. I have this yellow fluid flowing inside of a hose. So as the fluid flows through it, it constantly rubs against the hose. And this constant rubbing actually causes electrons to be transferred from one substance to another. So in this case, you can see that the fluid transferred electrons over to the hose. Okay, so the hose becomes negatively charged and the fluid becomes positively charged. Okay, it becomes dangerous if this fluid is combustible because when I have a build-up of charges, as the fluid keeps flowing, electrons keep transferring over to the hose, I will end up with a large quantity of negative charges on the hose and a large quantity of positive charge in the fluid. So whenever there's a build-up of electrostatic charges, okay, the charges would not stay on its surface because it's too much already, it's too saturated already. So the charges would jump. Okay, and this jumping of charges cause a spark. So when there's too much negative on the hose, the negative charges would want to move to the fluid which is positively charged because unlike charges attracts. Okay, and as it moves over to the positive charged fluid, okay, it jumps over to it because they are insulated, so the charges cannot just like that flow to it. Okay, the charges would jump over to the surface of the fluid. This jumping of charges is what we create a spark. Okay, and if of course the fluid is combustible like petrol, okay, then the spark will cause a fire or even an explosion. That's why it's dangerous. Okay, in the next section, I will be showing you a video about how
a dramatic video.
How an electrostatic fire started in a gas station. You can watch this video by yourself, but I'm going to show you the other video. Okay. Okay, you can watch. This lady is trying to pump petrol. You can see that she's wearing a woolen sweater and then she keeps rubbing her clothes as she's pumping. I'm going to fast forward. Okay, so she put in the petrol pump into her car. Okay, and then you observe her movement. She rub against her clothes again. And then she went into the car. And she moved out of the car and moved in again to the car. So there's a lot of rubbing with the car as well. Okay, and then she rubbed her clothes again and she touched. There. At the moment where she touched, okay, there's actually a spark being produced because what happens as she is pumping the petrol, she keeps rubbing on her clothes. Her clothes is a woolen clothes. So when she keeps rubbing, her body keeps rubbing against the car seat or her hands keep rubbing against her clothes actually gets charged up. So she is charged. Okay, so there is a lot of charges on her, and when she finally touched the pump parts, the charges jump over to the pump parts, and this jumping of charges causes a spark. And this spark, and because the presence of petrol flowing through the pump, okay, this spark actually ignites a mini explosion on the pump. Okay, let's go back to our slides. Okay.
It shows a dramatic.
Okay, the next example, you can see a video of burning.
So I'm going to burn something particularly flour. Okay. All right. If we have the lights down again, please. Thank you. Okay. Don't try that at home. Thank you.
Okay, so what happens here is when the flour is mixed with a lot of oxygen, and then you have a spark or any form of heat, okay, it will likely cause an explosion as well. Okay, other dangers, okay, is also because of electrostatic charging as fluid flows. So for example, you take a look at this, okay, I have a petrol tank. It's being refilled with petrol. So as the petrol gets refilled, okay, it passes through the hose and then into this tank. Okay, but because the petrol keeps rubbing against the hose, okay, so the petrol gets charged. Okay, let's say the petrol becomes positively charged. Okay, and so what happens is as the petrol, positively charged petrol flows into the tank, okay, it will induce negative charges in the tank. So all the electrons will flow up, okay, to this metal part of this tank. So we say that this truck becomes charged during loading of the petrol. So we don't want we don't want the tank to be charged up. We don't want the build-up of charges because dangerous. Later got sparks again. So what happens is we often do earthing. If you recall, earthing is the process of neutralizing any substance by attaching it to the ground. Okay, so I can easily do earthing by attaching a metal chain to the ground. So what happens is when I have a metal chain attached to the ground, it will ensure that the charges don't get built up in the tank because any extra charge will be neutralized by either the electrons flowing up or the electrons flowing down to the ground. So in this case, you can see over here, they attach a metal chain, okay, at the rear end to conduct the electrons down to the ground. And so when this happens, there will be no build-up of charges. And when with no build-up of charges, sparks will not happen, and therefore it will be safe. Okay, just take note that most of the time we don't really see this happening in Singapore because Singapore is quite humid. Okay, but if you go to countries with like winter seasons, okay, the humidity is very low. Okay, so for countries with very low humidity, static electricity can be quite dangerous. So it's like, for example, just now you see that the lady wearing the woolen sweater, okay, most probably is in a country with very low humidity. So another case is when in places with low humidity, as the vehicle's tires move along the road, the tires keep rubbing against the road. So again, there will be friction with the road. Okay, and this friction will again cause the tires of the car to be charged up. And when the tires of the car gets charged up, okay, it will induce charges in the vehicle's body as well. So sometimes when you after driving on the car for quite a long period of time, then you happen to touch the metal part of your car, okay, the outer surface of your car, okay, you get a small electric discharge, you get a slight electric shock as well. Okay, so to minimize this, nowadays we have modern tires and they contain some of the carbon. You should know that carbon can conduct electricity, or embedded metal mesh on the tires. So these tires are constantly touching the ground, so it will help to do earthing or grounding. Okay, help dissipate the charges to the ground to prevent the build-up of charges on the vehicle body. Okay, another one that is very important is for airplanes. Okay, you need to know that as airplanes fly in the air, okay, it constantly rub with the air, and this constant rubbing will again causes static charges to be built up on the plane. Okay, so how do we discharge? If you can see that on the airplane wings, there is all these long spikes. Okay, all these long spikes are actually discharge rods on the wings of the aeroplane. So as it flies, a lot of friction with the air, a lot of charges build up on the metal part of the aeroplane, the outer surface metal part. So it will be discharged through all these discharge rods. Okay, just take note that charges likes to accumulate at sharp points. Okay, so as you fly, okay, all the charges built up on the body, it will all go to these sharp points, okay, these sharp ends. Okay, and then as you fly, it will slowly be discharged through the air as well. Okay, so that will prevent the aircraft from being from having a spark. Okay, but then so far we have talked about the dangers of electrostatics. Okay, but there are also many useful applications of electrostatics. So some of the useful applications are as follows. They are often used in photocopiers, spray painting. It can be pesticide spraying, electrostatic paint spray. We also use it in our filtering of factory smokes and heart defibrillator. Okay, so I will only zoom into two of them. Okay, so one of them is paint spraying, or is often used in pesticide spraying or fertilizer spraying for plants as well. Okay, so how does it work is you have paint droplets flowing through the hose. Okay, so the paint droplets are all charged by friction as it passes through the hose or the nozzle. And because the paint droplets are all having the same charge, they will repel each other when they come out of the nozzle. When they repel each other, you will result in a very uniform mist because they spread out. Then the car itself, the car body or the plants that you are spraying it on are earthed, or they can be charged positive. The car body can be oppositely charged, or you just place them on the ground. For plants, they are naturally on the ground already. Okay, so you should know that you should recall that charged object will always attract to a neutral object, or it will always go towards a grounded object because charges want to be discharged, wants to flow to the ground. So these paint droplets will naturally be attracted to the car surface or to the plant surface. Okay, so another example is like this. Okay, so you have the nozzle is attached to a negatively charged, so all the paint droplets come out will be negatively charged and they will spread out because light charges repel. So you get a very uniform spray. And then the car body can be either earthed or can be positively charged, opposite charge. So unlike charges attracts, so the negative charge paint droplets will be attracted to the positively charged car body. In such case, okay, why do we use electrostatics? Is because number one, the paint will be very uniform because it spreads out as they are light charges. And number two, there will be less wastage of paint because of electrostatic attraction to the car body. It will stick onto the car body and instead of going everywhere in the air because of the attractive forces. Okay, the next one that we are going to go into discussion is electrostatic precipitator. So how does electrostatic precipitator works? Okay, it's often installed in a lot of factories that produce harmful gases. So the first step is you have incoming gas with a lot of unwanted particles, a lot of pollutants inside it, bits and pieces of particles inside it. Okay, then it will be passed through some metal grids that is negatively charged. So when my gas pass through all these negatively charged metal grids, my gas and my particles becomes negatively charged. And then it will pass through a chimney, and on the chimney there will be plates on it which is positively charged. So all the negative charged particles inside the gas will be attracted to the positive charge plate because unlike charges attracts. And then so when the gas finally leave the chimney, it will be clean. There will be no particles because all the particles which is negatively charged will be attracted to the positive plates. So the gas that comes out will be clean. There will be no large particles. Okay, and then a hammer will regularly knock this positive plate to knock out all the particles. Okay, on all the dirty particles in the air. Okay, so this is an animation. You have dirty air passes through a negatively charged plate, becomes negatively charged, attracts to the positive plates, and then you have clean air going through it. Okay, so this is how electrostatic precipitator works. Okay, that's the end